In this video, we're going to be graphing the function, the absolute value of x plus 1, and then on the outside of the bars, we have minus 2. Then we're going to describe the transformations. So to graph it, we're going to use our general rule, inside affects x and opposite. So we see x plus 1, which means we're really going to be doing x minus 1. Outside affects y and in the same way. We have minus 2 on the outside. So we're going to do y minus 2. So this is our transformational rule that we're going to use. Now, if you know what this shape of the absolute value graph looks like, since these are just translations, you can easily move them. I'm going to keep a consistent method throughout everything. So I'm going to look at the absolute value function. And throughout the year, we're going to be using the x values -1, 0, and 1 to assist us in graphing each of our functions. The y value with the absolute value of -1 is 1, absolute value of 0 is 0, and absolute value of 1 is 1. So that's the three order pairs that we'll be using with the absolute value function. And you can see them on the basic graph of the absolute value function. Those 3 points are indicated. So now that we have our points that we're going to use, we're going to go ahead and apply our rules. Go down and do all my x rules. So my rule for x is x minus 1. So -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. Go back through and apply the y rule, which is y minus 2. 1 minus 2 is -1. 0 minus 2 is -2. And 1 minus 2 is -1. We have our 3 points, so we just have to plot them now. So we have -2, -1, -1, -2, and then 0, -1. This is the absolute value graph, so we'll go ahead and draw the absolute value function's shape through them. And there, that was horrible. Try to do that last part again. There we go. There we have that. We still have one more thing to do. We're supposed to describe the transformations as well. So based on the rule, we only have addition and subtraction in the rule. Therefore, we only have translations. So this graph has been translated. For the x rule, we have x minus 1. So 1 unit. If you subtract 1 from x values, it will be taking it to the left. And 2 units. So the y rule is y minus 2. If we subtract 2 units from the y, we're going to be going down. So we've translated it 1 unit to the left and 2 units down. So in this video, we're going to be graphing the function f of x equals negative the absolute value of the difference of x and 2, and plus 3 we have on the outside. After we graph it, we're going to state the domain, range, interval of increasing, decreasing for the function. So, going through, let's find our rules first. Inside affects x and opposite. I see x minus 2 inside, so we're going to do x plus 2. Outside affects y and the same, so I see the negative on the outside, which is like having a -1 there, and add 3. We take care of multiplication first, so we're going to do y times -1, then plus 3. So those are our transformation rules. Our parent function that we're doing is the absolute value function. We know this because of the absolute value bars in our equation. And the 3 order pairs we're going to use are the 3 that will help us get the V shape. So there we go. That just comes from the basic graph of the absolute value function. And go and do all my x rules. So x plus 2. So negative 1 plus 2 is 1. 0 plus 2 is 2. And 1 plus 2 is 3. For my y rules, y times negative 1 plus 3. So 1 times negative 1 is negative 1. But I have to add 3. If I add 3, it is 2. 0 times negative 1 is still 0. Plus 3 is 3. 1 times negative 1 is negative 1. Plus 3 is 2. So I'm going to plot my points. 1, 2. 1, 2. There we go. 2, 3. And 3, 2. And draw the shape in. In addition to graphing it, we were asked for domain, range, and intervals of increasing, decreasing, or specifically just increasing, I guess. So domain, range, and increasing. So as far as domain goes, if we do the same thing we normally do, from the left side, we hit the graph right away. It's running off. So negative infinity. From the right side, same thing. Positive infinity. So unless the graph is restricted, all transformations done on absolute value functions will still give you all real numbers for the domain, assuming you aren't restricting the domain of the function in the first place. Range. So for the range here, we got blank less than y less than blank. From the bottom, we hit the graph, it's running off. So negative infinity. From the top, we get to the graph right there at 3. It is part of the graph, so we're going to include it. And that's it. As far as increasing, decreasing goes, we want to separate it at the extrema, which would be at 2. So we'd end up with 2 separate intervals. One from negative infinity to 2. And one from 2 to infinity. The increasing one as we go from left to right is the first interval, because as you move from left to right it is going up. So the increasing interval is negative infinity to 2. There we have it. Okay, this is going to be doing example 2 in a slightly different way. We're not going to be graphing this time. We're just going to focus on domain, range, and intervals of increasing here. Because there's a way you can do that just by looking at the equation, so long as you understand transformations in the parent function well enough. Domain is pretty easy though for all absolute value functions, so long as there's not a restricted domain in the first place. Domain will just always be all real numbers, which is negative infinity, less than x, less than, positive infinity if you prefer that. The range, you can figure out the range, intervals of increasing, decreasing, by just knowing 2 facts. You need to know where the vertex is, and you need to know whether the graph has been reflected or not. So, if we look at the transformations, we have x minus 2, so that means we're going to do x plus 2, and I have times negative 1 for the y values, and plus 3 afterwards. So, normally the range in an absolute value function is y greater than or equal to 0. Of course, there are other ways to actually write this, but that's the condensed version, and that's normally what the range is, because absolute value graph normally, as its parent function, starts at 0, 0 and goes in the upward direction. Well, if we're going to do the transformations on this, we're going to multiply by -1. Multiplying 0 by -1 doesn't actually do anything. However, when you multiply inequalities by -1, you're going to end up flipping the inequality sign. Goes back to when you solved inequalities like this. When you went to get rid of the -2, you divided by a negative and had to flip the inequality sign. So multiplying 0 by -1 doesn't actually do anything. However, we still have to add 3. I should say, clarify that again. Multiplying by -1 doesn't do anything to the number, but does change the inequality sign. And we'll add 3 to 0. So 0 plus 3 is 3, which is the same thing we got previously, just without the infinity. Negative infinity less than y less than or equal to 3. Same thing we got earlier. Increasing, decreasing. This one is a little bit harder. Normally, for the absolute value function, if we focus on the parent function, which I have kind of graphed over here, normally the parent function has two intervals, negative infinity to 0 and 0 to infinity. Normally those are the two intervals, and normally the first one is decreasing, second one is increasing. That's how it normally goes. Well, our transformation that will affect the intervals is the x plus 2. So if we add 2 to each of the x values, adding 2 to infinity, negative infinity really doesn't do anything. Adding 2 to 0 will make it a 2. Adding 2 to 0 will make it a 2. And adding 2 to infinity won't do anything. So those are the new intervals. And the words increasing, decreasing are dealing with the y values. So they will stay the same unless there is a reflection, which means they'll stay the same unless you're multiplying y values by negative. Because we're multiplying y values by negative, what was once decreasing will be reflected and turned into increasing. And then what was once increasing will be reflected and turned into decreasing. So decreasing becomes increasing, and increasing becomes decreasing. So the intervals of increasing is, as we found earlier, negative infinity to 2. So the more comfortable you are with transformations in the parent functions, the easier this is, and you can do it without even writing out graphs.